in this example, we've got this table. Everything's in BTUs, and it's for a thermodynamics cycle consisting of 4 different processes. Okay, and we basically want to fill this table in and then determine if it's a power cycle or a refrigeration cycle. Okay, so first thing we're going to do is we'll start with the energies. Okay, and remembering that's a cycle, it's going to begin and end at the same property, same state. That basically means that delta U equals 0, as well as delta KE, delta PE. All of these have to add up to 0 because, again, I begin and end at the same point. Okay, so that means that I get 72 plus 64 minus 97 plus U 4 to 1 equals that 0, which means U 4 to 1 equals well, I guess I have to figure it out. Don't have my notes here. Equals negative 39. Okay, so I plug that in right there, which means all of these have to add up to equal 0. So using that same concept for kinetic energy and potential energy, I know this guy has to be 5 because negative 5, 0, 5, 0 have to add up to 0. This guy has to equal 3 because I have to balance out that negative 6. So that total all equals 0. And then remember, delta E is just the sum of all of these, meaning this this guy here will be 72 minus 5 minus 6, so that would be 61. This one would be 67, adding them all up. This one would be negative 92, and this one would be negative 36. Now, as a check, you could add up all of these and prove that the total energy equals 0, and I can do that pretty much in my head. The positives add up to 128, and as well as the negatives adding up to 128. Okay, so that's how we do that. Now, for a cycle, again, those all add up to 0. Now, the other thing I know is the first law equation, which is essentially the total change in energy equals Q minus W. Now, these shouldn't actually be deltas. Those should just be Q's because Q and W are based on the process. There's not like a change in heat or anything like that. So that's just a little typo there. So again, delta E equals Q minus W. That means for that equation to work out, W here has to be negative 61, right? Because again of that minus sign. So 0 minus a negative 61 equals 61. Okay. This one would be 23 because 90 minus 23 will give me 67. Okay. Q here is going to be 0 because 0 minus 92 gives me negative 92. And here, Q has to be negative 36 to make that. Now, the last check I can make, and why don't I go ahead and do this because I guess I need it for the answer, is I can basically prove that Q of the cycle equals work of the cycle. Okay, so Q of the cycle is basically 90 minus 36, which would be 54, if my math is correct. And I should get the same thing for the work of the cycle, okay, which is going to be minus 61 plus 23 plus 92, which also equals 54. Okay. Now, to answer this question, the main thing that comes from this question is because this work of the cycle is greater than 0, that means I'm getting work out of the system from our sign convention, right? When the work is positive, work is being done by the system. That, by definition, means this is a power cycle. Okay. So again, the main thing here is recognizing that the properties have to sum up to 0 for the cycle because they begin and end at the same. My first law equation, delta E equals Q minus W, and then Q of the cycle equals work of the cycle. And if work is positive, it's a power cycle. If work is negative, it would be a refrigeration cycle.